All right, Mark here, still cooking the books, bringing the info. So I'm just taking a little breather. I've been studying calculus all day, on and off. My eyes are killing me sitting here looking at this computer. But anywho, so I just want to share something real quick with you guys. I've said it before. I'm in finance, and there's something called options, right? Options are derivatives, derivative products, and without going too much into the jargons, because it can be a little confusing, I'll keep it simple. It's a contract that allows you to buy a stock at a set price in the future, right? Now that contract has a cost. That cost is called a premium. The premium goes up and down depending on the price of the stock. If the stock price goes up, the premium goes up. If the stock price comes down, the premium goes down. So the premium is tied directly to the appreciation or depreciation of the stock price. Okay, that's it. If you understand it, you understand. If you don't, you don't. That's it. It's complicated, so I don't want to get too complex. All right. Why I brought that up is because I've been studying calculus, right? And I just started studying calculus maybe a week ago, or maybe 2 or 3 days ago. And the reason why I started studying calculus is because, as you know, if you watch my videos, I study quantum physics, particle physics. And if you study quantum physics and you study Schrodinger's equation, you study all these different kinds of sciences, it eventually ultimately leads you into math, namely calculus, not just any math, specifically calculus. And the reason why is because calculus has to do with integration, which is integral calculus, or differentiation, right? And what that means is it breaks things down into very small pieces, and then it measures and looks at their behavior and how these things change over time, and it expresses it numerically. So it's a number. Its language is numbers, but its language tells you how things change over a period of time, and again, numerically. So calculus is important. I'm learning it's important to understand it, not so much to be a mathematician, but to understand human behavior. You see what I'm saying? Because calculus is used in population dynamics, right? It's used in economics. It's used in particle physics, and all of that ties into human behavior. If you put it like this, if you study evolution, you'll understand yourself, and you'll understand survival of the fittest. You'll understand survival mechanisms. You'll understand life. You really look out into the world and you see the world totally different, right? Understanding evolution. When you start to have a basic fundamental understanding of calculus, it's the same concept. You see the world entirely different. You see things completely different. You start to connect dots that you would never otherwise connect. You start to see correlations that you normally would not see. And this segues me into what I want to talk about. There's a formula in calculus called derivative function. Derivative functions have to do with correlation. And what I mean by that is this. It's complex, so I'm going to keep it simple and tell you why it's important to understand this and why it applies to me, to you, and to life in general. A derivative function is a measurement, right, of the rate of change in a variable, let's say a variable y. Right, we'll use the letter y. It's a measurement of the rate of change in the variable y in respect to the variable x. So y has some correlation to x. What goes on in x affects y. What is being morphed, changed, varied in y is a result of what's going on in x. So we find out what's going on with x, we'll be able to determine what's going on with y, and we can measure the rate at which y is changing, morphing, varying. We can measure that rate. There's a measurement where you can measure the rate of change and the behavior of y based on what is going on with the variable x. And it is called in calculus a derivative function problem, or derivative functions. So the derivative function of y is based off x, right? There's a correlation, right? A connection. What happens with y affects what happens with x affects y. This is calculus. Now, again, this is mathematics, but the reason why these formulas are why I find this is important is because if we understand these formulas, if we understand these mathematical functions and these mathematical equations and laws, we can transfer the basics, the fundamentals into your everyday life. Right? Again, like I said, this stuff is used by economists. It's used by scientists, quantum physics, particle physics. If you study, and what led me to calculus is because I've been studying. If you watch my videos, I've been studying quantum mechanics and classical mechanics, Newtonian physics, and Einstein, Schrodinger, and Max Planck, and Niels Bohr, and Young, and all these scientists. Been studying them for at least a good year and a half, maybe a little bit, maybe I'd say at least a good year and a half, 2 years now. And it led me to calculus. It ultimately leads you to calculus. You can't study physics and not end up in studying mathematics. And again, not just any mathematics, specifically calculus. So okay. So why I'm doing this video? Why am I saying okay? So on the getting back to this equation or this formula, this expression, which is derivative functions. How do you apply that to your life? Right? How is that practical? And I'm not talking about if from a corporate perspective, like you're in finance, like I am, or anything, or economist or anything like that. But just on a practical day-to-day interaction, how do you apply this physics, right? Not this physics, this calculus equation. Well, it's interesting because if you look at just the fundamental, the concept, conceptually, it's an amazing concept because it's asking you why is changing, the variable y is changing, and you can measure the rate of change, the behavior. You can, there's a way to quantify that based off x, the variable x, like I said before. So now take that and you put that into your life and you say, okay, y is tied to x, and what goes on with x affects y. You personally, the people that's around you, the people that you're tied to, the people that's in your life that you're close to, right, will always have an effect on you. They will always change you. Again, listen to the mathematical formula, the derivative functions in calculus. Y can be measured. The changes in y is measured. The rate of change is measured in respect to the variable x, because y is tied to x in this equation. So you're tied to people. You might not be tied to them directly, but you're tied to them indirectly. Or in these equations, right, there's multiple variables. So what that means is you can be tied to someone, maybe not directly, but indirectly, right? So there's a degree of separation, maybe 2 or 3. Right, so there's 2, 3 variables in between you and point. They're called coordinates, right? So so you use math to explain behavior in humans, and how people are changing, or how people are behaving, or how people conduct themselves will affect you. It will affect you. There is no escaping it. There's no way around it. You will be affected. Your change, obviously, no one's going to sit around and measure your rate of change. But if you're conscious of this, you can see how an association, a correlation with someone is affecting your life. How there's a thing, this is not necessarily calculus, but it's in the arts. It's called osmosis, learning through osmosis. And learning through osmosis means that you have an uncanny, an abnormal ability to absorb knowledge without necessarily sitting down and consciously, scholastically studying the knowledge, right? You just have this uncanny, mysteriously eerily ability to absorb information without necessarily putting in all the labor as someone else like myself. I sit and study for 7, 8, 9, 10 hours. Like I do 9 to 5s in my research time, right? Obviously, I go outside and I run, I jog, I do a lot of running to take breaks just to let the brain relax a little bit and to kind of like just marinate and just kind of, what's the word I'm looking for? Ruminate. Yeah, ruminate could be good. Gestate, that's a better word, which means just to develop, right? To develop the information, ruminate on it, develop it. So I do take breaks. I jog, I go outside, there's no gym now, so I got to go out and I run, or I'll do some push-ups or whatever, some activity just to kind of like let the brain relax. But I say, I don't want to digress. The point is, osmosis is the osmotic process. Is you absorb information, you absorb things in your environment, right? It's not just information in terms of studying. You absorb things in your environment subconsciously or subliminally, meaning below your level of awareness. So all of us have the osmotic process, some to higher degrees than others. So when you are in relationships with people, right? And if you represent Y and the person you're in a relationship with represents X, what's going on with X is changing you. And whether you realize it or not. So in calculus, we're learning that it is what's the takeaway is that it is vitally, critically, crucially important that you study your circle. You study who you are correlating with, right? You study who you are tied to directly or indirectly. You study the degrees of separation you have between you and certain people. Because what goes on with X, which represents Randy, right, affects Y, which represents John, right? What goes on with Sarah, that represents X, affects Tony, which represents Y. So you have to be very careful who you tie yourself to. That's what this mathematical equation and formula in calculus, at least that's what I would draw from this in terms of how can I put this into practical practice in my life. It's you have to be very careful who you are correlated to, because what goes on with X is measured. There's a rate of measuring of the changes in Y, and this is calculus. It's called a derivative of functions. You can go look it up and do your own little study on it. But again, I don't study calculus to be a mathematician. Nowhere am I trying to be a mathematician. I just want to have a broader understanding on nature, and wherever the knowledge leads me, there you'll find me. Till next time, I'm tired. Peace.